Right. Okay. It was good to hear from Yannick about power takeoffs and the ECPTOs we now have. That's Bank's bread and butter. As Yannick mentioned, there's some really interesting stuff going on within the electric chassis PTO world, particularly. So watch this space. Yeah, there'll be announcements and products coming out soon. But we'll just change direction a little bit now and talk a little bit about vehicles with the technical marvels we have outside, with all the focus on electric vehicles at the moment. We're going to spend the rest of the day talking just about that. And I noticed that there's a couple of Teslas, a couple of ID3s, and plenty of electric vehicles that have come here today. Anybody that owns an electric vehicle knows that charging is an issue and a challenge and a topic in and of itself. So therefore, we invited Morten Jensen from NEWTEK to come and talk to us about charging for trucks. So he's been given a free hand to tell us whatever he wants to talk to us about. I think he's going to talk about various models you can look at the charging. He's going to touch on Megawatt Charging that Mikael mentioned earlier on. The word is yours. So
Thank you.
There you go. Thank you.
Yes, and thank you for letting me having this theme about electric charging. I think you are fairly familiar with the different differences between AC and DC, and if not, then please just ask me. But our company is placed in Odense. We are representing the Dutch company called EcoTap, which is part of the Grand Group. We have signed a distribution contract with FSEC, which is a Portuguese, a little like ABB company, also producing power plants, big transformers, and so on. We have the Polish Eco. They call it NEWTEK, but we short call them Eco. And then Finnish Kempower. And if you look down here where some of Bank's PTO equipment is exhibit, we have a mobile DC charger, 40 kilowatt hour, that they have borrowed here for some testing of some of the electric trucks. It's actually belonging to Keolis, the bus operator, and lent out from Odense, the Odense depot. I will go through our portfolio, some charging technologies as they are now and in the coming future. We will talk a little bit what's possible within the battery electrical vehicle, battery electrical trucks right now, and also how do you make a strategic decision of where to go, what to convert from fossil fuel trucks to electrical trucks or fuel cell trucks, whatever, gas, and then also the coming years for infrastructure. The infrastructure is it's like when we talked about personal electrical vehicles, what we call EV shortly. It was always what comes first, the hen or the egg? And it's exactly the same here with trucks. It's right now just a larger problem than what the normal personal vehicles are facing right now. We do purchasing, we sell hardware, we make a financial offering through leasing. We can install. We have back-end solutions, different back-end solutions concerning which purpose there is. Some run electrical trucks right now without any back-end, but the future may be that we connect it to whatever fleet management system that you have. And then, of course, service. It could be service from electrical service, It could also be that we help you to monitor and control chargers from a cloud connection. There's many possibilities. Within projecting, we can do sketching, modeling, dimensioning, and calculation of a new site that you want to have. This one is a new greenfield site where you combine trucks and personal vehicles, because that way you in the beginning now get a critical mass of charging. Otherwise the capex would be quite heavy unless you have a big fleet of electrical trucks, of course. The buses right now is a front runner within the larger vehicles, and they more or less all want their own depot, and they are more or less also greenfield projects. We have done last mile distribution solutions for last mile distributions. Our key customer in Denmark, but also in whole of Europe, is DHL. We have made for DHL Freight, for DHL Express, and for DHL Aviation. Aviation has a big hub, new hub in Kastrup Airport, which will have solutions within. This is the same hub actually where the vans, big hybrid, charging hybrid, and normal hybrid and electrical vans will hook up, and when they are either loaded or reloaded, we will charge them with just AC charging. But they will return many times a day, so we keep them charged so they don't have any stops. But also for their personal parking lots, and lately I haven't got a picture, we also supplied some DC charger, actually 120 kilowatt DC chargers, and they all have to be branded DHL. There's a branding policy, we have to follow that. We can do that for almost anybody. Cost a little bit extra also on the delivery side, but that's something that we're very good at. We do for buses. Many bus operators also financed through municipalities have done the front running within heavy vehicles, electrical vehicles. This is TransDue. We have some others also for Midtrafik in Aarhus. They actually have this 160 kilowatt fast chargers. We have done within the recycling business. Sharp eyes can see this pre-zero, but also for Uberser, which are also represented here. It's not the depot here in Sønderborg, but in Copenhagen. And we also, we are not so brand oriented in concern to the trucks OEM producers. We can deliver, if it's Scania, Volvo, DAF, Mercedes, those are the main four of today. MAN perhaps also. So we can supply almost from show. Our leasing solutions are done through DLL, which is part of Rabobank, situated in Eindhoven, Holland. We work with their NEWTEK affiliate, which is placed in Copenhagen and Vejle. We can make a leasing solution financial leasing solution up to 80 months. So you can pay back and, with a small return sum. The reason why we chose DLL is that they are doing much of their business within distribution and manufacturers, dealers that are working with these new solutions that are really providing this green conversion that we are going to make within the next 10, 15 years. Okay, I will talk a little bit about the charging technologies. I don't know, you probably know that on AC, we run through an internal charger that is built into the car. We supply AC, and then this converter or this charger will convert AC to DC. It's a little bit different on the DC side, and the reason for the big cabinets are that we build in the inverters in the cabinet. We sort of took them out of the car because otherwise we would be restrained to probably maximum 44 kilowatt AC. So here we can align with the battery management system on voltage and amps, and then supply the vehicle battery. By far the cheapest way to charge is to charge by AC. The equipment that charges AC can go up to 44 kilowatt on a single charge. And then we can also make stands that has 88, so 2 times 44 with a split load between the 2 charging points. That we have done for Uber with some of their e-trucks that will convert it, Mercedes. It's also cheapest to install and to service. It has many good things, but it also has constraints. So the batteries on a truck with AC is likely maximum 200, 220 kilowatt hours right now. And so we can get perhaps 150. I say 180, but that's with good wind and sunny weather and things like that. So it's likely more in the range of 150 kilometers. The next level is to have fast chargers where we can supply up to 60 kilowatt DC. They actually range from 20 to 60. The mobile charger here on the display from Kempower supplies either 40 on one socket or charge point or 2 times 20. So that's for boosting. If you have like FERC hydraulic, which are also doing some of the Norba equipment for these refusal trucks, they have mobile charger, and a lot of the bus tool shops also have one. So to boost and to get the truck running, if it's very low on capacity, then it's a very good one. But it's also built for going outside. It's not an indoor equipment. You can go outside. It's IP55, and it's quite heavy-duty equipment, but a little more expensive than a stationary charger. And then also, when you compare to AC per kilowatt, it's probably 2.5 to 3 times as expensive to invest in DC. but it's also faster. So you gain something you have to pay upfront. 160 are the first high pressure chargers, or ultra fast chargers as they also call. They are mainly not liquid cooled. You have to make a step up from 160 kilowatt before you actually cool down the cables. But you can get them either in 500, and they are most likely now in with 1,000 up to 1,000 volt DC. The tolerance is about 200, 250 to 1,000 volt DC. But again, it takes longer, it's more expensive also to install these equipment. And they are getting heavier and heavier. Now we are, for the largest ones, we are almost at half a ton. But to the inverters and electronics, we also need some fan cooling. And so everything together, we are going up in weight. And right now, the latest, there are some that has maybe 400 kilowatt, but the average is about 350 to 360. And for personal cars, they are with 2 charge points, so they can split up into 175 or 180 per charge point. And they can be put together with dynamic loading so that we don't get any problems with spreading the whole load. So in our management, dynamic load management, we can make sure that we have enough power on each socket. This is the one that is on display down here that Banke has using, but we have a very low cost one that's pure AC, only for boosting. There's no back end for this. This is on off and you can use it for that. The others are able to connect to a back end via a protocol called OCPP 1.6 and be connected by Sky Cloud connection. And it can be all up to 80, and 80 with either 2 charge points or 1. So 80 or 2 times 40. What is the trucking? What is the possibilities right now? And I took the liberty not to take any of the big OEM producers right now, because I'm really not a fan of any of them. I'm a fan of them all. So do not make any commercial preference. Then I chose the company called DW, which is short for Designwerk, and it's placed in Thun in Switzerland. And it's called, it was actually called the Tesla of Europe. They were very early on producing some electrical vehicles, and very soon made a connection to Volvo and Daimler. And right now they are building most of their business on the product line from Volvo, the F trucks. And then they build in their own, like Banke do here. They build in their own equipment that they source from various manufacturers, but also some they produce themselves. I took this one out. This is semi-truck. It's actually can be equipped with different battery packages, and depending on what the usage driving pattern is to be in your case. But you can reach up to about 500 kilometers. And that is a conservative estimation, because actually last year they broke the world record in reaching almost 1,100 kilometers in one day. Of course on the track, but considering that on that day it was only 14 degrees in outside temperature, and there was quite a wind also, 17 seconds wind blowing. So it was of course theoretical, and it was an unloaded truck, but it showed that what can actually be done under this condition. And they reached this mileage of using 52 kilowatt hours per 100 kilometers, which is of course very, very good. and it's not to be copied in practical sense. It's probably more likely when we look on the same truck that went on to service for 3 months, a steady route of 300 kilometers between Basel and Zurich, sometimes with a carriage or a trailer behind, mostly not, but loaded and weighing 9 tons instead of 15.5 tons. There you reached almost the double or the half of the consumption. But in reality, the Futuricum, this is the brand of the truck. Designwerk means that you can probably reach about 160 kilowatt hours per 100 kilometers right now. But as we talked about with someone also, we're down at the electrical trucks, things are going very, very fast. Every 3 months, there are improvements. Some of these figures from last year maybe have to be raised with minimum 10%. And the future is just going up and up. Batteries are getting better. The components, the metals that we are using in batteries are getting better. But this is what's practical possible right now. When you want to charge this truck can be charged by AC 44, takes 14.6 hours. It can also be charged with DC 150 or 350. And there it takes, of course, significantly shorter time. So again, I know that some of the recycled trucks that Urbaser has, AC, have about a stand of maybe 11 hours before they have to be operated again. You're not allowed to use all that time, but to maybe make them a buffer. So they charge every truck with about 5-6 hours, and then they are ready again. But many times when they come back, they haven't emptied the battery. So we also have to make sure that we don't exceed too much in our reload. What to choose? This FCEV down here, or this is one from Volvo, or an electric, fully electric, or a mix. I don't know. Very exciting future. But I think both of these technologies will play an important role in the future. The long hauling, very heavy trucks will probably tend more this way. But again, if the batteries are following the same development pattern as the last years, then it could also be that battery can make sense, at least with ranges of 500 kilometers. And then you have to extend the range. But we have to do something now. We have to make a conversion. I don't think that's new. It's something that we will all have to chip in on. Some of you are maybe more ready than others. The city buses are definitely ready right now. And we see one city after another changing their gas and diesel trucks into electrical, diesel buses into electrical buses. And some of them only needs to be charged once in the depot in the night, and then they can run the whole day. Others have to make some destination charging by either pantographs or other DC equipment placed somewhere on the route. But one of the things that you have to do, and you have to do it yourself, or you have to have help, then you have to do a total calculation of ownership, where you cover the indirect capex cost, direct cost, indirect cost. You have to see, put in the pros and cons between the different technologies, and that's probably the only way you can make your own decision. And something is telling us that the transportation of trucking in Denmark has about 12% CO2 emission, covers about 12% CO2 emission. And with the foreign trucks that are passing and doing cabotage, then they are probably reaching about 19, 20. And I know that there's some attention on this right now. We know for sure that electric truck will bring this dramatically down compared to the main gas and diesel trucks. Here are an example of total cost analysis made for electric buses. Every total cost analysis are different and are suited to your purpose and your view on the different possible technologies. But here you can see that within the first 2, 3, maybe 3 years, it's of course less expensive to run diesel or fossil fuel truck. Especially the capital cost. Right now, we don't have a financial support in Denmark like they have in Germany or in Holland, where they cover a very large portion of the difference between buying a diesel truck and running a fuel cell truck or a electric truck. But we hope to get the same solution in Denmark, because then I think that really will move the whole thing forward. But by year 3, 4, then there is a close race, and then it really extends, so you get a lot of especially the OPEX costs back, because running on electricity and doing service on these trucks are much less than on these fossil fuel trucks. And by here you can see here they cross each other at year 3, but this is just this case. But I think around 3.5 years is very typical that you see also. But what does this help if you want to go outside of Denmark? You do long hauling, and where are the chargers, and what are the depots? How are the depots equipped? How are they built? I can only say that right now they are not built for trucks. They are likely to be built for trucks, but they are maybe also trying in the nearest future to cover both personal cars and trucks together, to have a critical mass for their capex, pay back their capex. So we just hope that, and by advising our customers, that we can get enough room for all of them to maneuver within the same spot. I know that there is a big truck stop being built very soon, or it's projected right now around Horsens, I think, about 100 kilometers from here. And I hope that charging is part of it. Maybe also hydrogen, I don't know, HVO, but they're all related to some large vehicles that has to maneuver. This is the condition. This is from Norway. This is Circle K. Circle K has opened up for trucks. Right now, this driver is not following the rules. He's supposed to unload his trailer before he goes to the charger. You may be able to charge on these existing chargers. You may not, because again, normal personal car, except for the new Ioniq and Kia EVs and Porsche, are running 500 volt, and that's not suitable for most trucks. They need higher voltage. So, but the latest ones, as I told you, can go up to 1,000 volt. So they have a tolerance that covers also trucks. But it's very difficult to maneuver this big Volvo. And also, you can see, to park in these spots, you have to do some tricks. And sometimes it ends like this. And this is an ABB charger, probably costs around 400,000. And then installed, it's over 500,000. Hopefully it's not destroyed, it can be repaired, but again, have to park between passenger cars. So we need to do something else. And in the US, they have started also, because we are now talking mega charge. Right now, Charin, which is a group of mainly German car producers and some of the largest charging companies, they are meeting in Poland at ECO to talk about this mega charge norm that has to be brought out into the world within the next 5 years. And so you need to have dedicated places because you also need some very heavy transformer standing here. And if you want to have also hydrogen electrolytic equipment and something else, you need space. And so you can imagine the space for trucks has to be much larger. This is from I think Colorado, where they have done some test of a new way to have trucks coming in and driving out in different ways without hooking off the trailers, but also buses. I think there's a school bus. Okay. There are many initiatives around, not so many in Denmark yet, but in Holland. Holland is by far the country with the highest density of chargers. It's much higher than Norway. Totally, they have many more chargers than in Norway. Norway have most electrical cars, but of course they also 4 or 5 times as many people living in Holland. But they do like in Germany, they say, okay, if the diesel truck costs 100,000 euros, we will compensate the difference by about 50%. And in Germany, I think it's more, 60+%. We need some of the same initiatives to actually cut down the capex barrier, because I think that's one of the reasons why we don't see more of you converting right now, also for long haul. And then we see also a new company, NEWTEK, which has a strategy of going to build charging station for trucks and vans. So they're actually finding this as a segment for their business. And of course, we would like to see more NEWTEK like companies in our area. But I think also that, sorry. Already now they have 8 stations placed in them. And they have also a strategy of going into Germany from the west side in the Ruhr district, and then they want to go also to Belgium first. Okay, latest and just introduced in Oslo on the latest is Megawatt Charging, the new MCS protocol. It's been, of course, it's by CCS standard. You can go up till around, in theory, 1,000, almost 1 megawatt. But you probably stop around 500 now, and then you will introduce this new standard with a new plug for transferring these higher and maybe higher voltage also capacities. And it's not only for trucks. Don't start dreaming now. It's likely also for trains, battery-driven trains. It will be for electrical, semi-electrical airplanes. It will be for boats also. So there's many that are interested in getting these charge capacities. But of course, some trucks will be equipped, and instead of going to introduce two standards for sockets, then the MCS should be backwards compatible to the CCS standard. Instead of having the same problem that we have with CHAdeMO, which are not suitable for any trucks and are probably going out of the European market very soon. So you should be able to charge within reasonable time. And now we are talking minutes. We are talking situation just like you have on filling up fuel or hydrogen. We also will see some areas where you don't have enough capacity. You don't have enough amps to actually lay out the charging that you need. So also to balance the net, we will see more of these battery supports coming out. There are Danish company that is working very closely with, I think, Circle K. There are some German companies. Some will build them inside of cabinets, DC cabinets. They are very big, but some will also boost by a separate battery. And then induction capacity is not dead yet. Momentum Dynamics, American company that has financial support also from Volvo, are doing many tests right now. They have moved from personal vehicles up to larger vehicles and trying this out for buses, because buses has a fixed route, they have fixed stops. So it's much easier to test. And it's working just like your inductive oven. It's two coils where you induce AC, very high frequency AC into the one coil, and you rectify, invert the power that is coming out and directly to the battery of the vehicle. And you have a ground clearance about 20 centimeter average. And it can be equipped on existing battery-driven vehicles, or it can be delivered as new. So I think also we will see this one. And then, of course, we are also talking about now swapping batteries, but everybody here knows what happened to Better Place. So I think it still has some, it may have a future. We are seeing it now. It's being tested in Norway from NEO, and it's quite impressive. It was impressive also from Better Place. It just didn't have any cars to actually build up a critical mass business. So these are the possibilities, but I think plug charging will be for the trucks for the next 5 years. And then some of these will come out and take part of the market. We will see how many battery-driven. Okay, well, that's was my last. Are there any questions? And if you want to see who I am and maybe connect, then there's a LinkedIn address. But we are placed closely to the motorway, so if you would like to talk more about charging, if you have a charging project coming up, then just give us a call. Maybe we will be your, you'll be our next customer. we'll be your next partner. Any questions? Yeah.
I was wondering because some of the existing chargers are quite noisy,
Yeah.
and sometimes it's been suggested that a truck can charge during the rest period. But if the driver wants to sleep next to a charger that has this high tone, I mean, how's the sound on, for example, a 300 kilowatt charger?
The best ones are below 60 dBA. So we cannot make them without noise. It's just like the trailer down there where you had the traditional diesel-driven cooler.
Okay, so it's not worse than that.
No, you can't, with this amount of power, you cannot make any. We try to make some passive cooling, but you have to do active fan cooling. That makes noise. But we have some EMC rules that we have to follow. We also are aware when we make depots that we don't build them up too close to normal residents. But if you have truck stops, we try. Some of them are down to 55, but they're very new, so it tends to go that way, that it becomes less noisy. 55, 60 dB. Any more?
When you have a wireless charging, I suppose that there would be a loss of energy.
No. The same loss as in a plug charge. Yeah. So the loss you have in a cable is similar to the loss you have with a gap. And it doesn't matter if it's 30 centimeter or 20 centimeter. It doesn't significantly go up. I also thought that. But about 96% efficiency.
Is your product portfolio shown on your webpage?
I don't know yet. We are working on a new webpage, but I will give you another link where you can see it. So,
Anyone? More
Yeah.
questions? Okay. Thanks for that, Morten. It was really good. It was really good. It was good to hear about what's going on. It was very good to hear about megawatt charging, and I must say I'd overlooked the fact that megawatt charging would be relevant for boats and planes and trains. Yeah, so I guess if there are multiple applications that are driving that, then
I think you are getting an electric train from Alstom to run here in Sunderland. Yeah. That's
right. We're a little bit behind. 15 minutes, so lunch is downstairs. Yes, Percival is here to provide you with lunch. He has all the usual favorites and some vegetarian options. So there should be something for everybody. Don't be offended at the fact that there are vegetarian options. We wanted to take care of everyone to the plan. Can we be back by 1:45, please? Yeah. So grab a lunch, have a look around, look at the trucks. We're back at 1:45. Okay.